Topic 4, Algebra 2, expanding a bracket by a number. So sometimes what we have in maths to make things look a bit nicer and a bit neater, and especially whenever it comes to the order of operations, brackets can be really useful. Whenever it's all numerical values, it's easy enough to sort out, but whenever we've got algebra involved, it's not quite the same. So quite often we need to undo the brackets by multiplying them out. So in this example, we've got 3 upon a plus 2. So there's a 3 and then the a plus 2 in the bracket. And the most common mistake that people do is that they multiply the a by 3 and they do nothing with the 2. But what we should remember is that multiplying is just a quicker way of addition. So 3 multiplied by a plus 2 is really saying that we've got 3 lots of a plus 2. So we have a plus 2, and a plus 2, and a plus 2. And we have 3 lots of those, and they should be added together. And we know with our Algebra 1 work about collecting like terms. So we can see that there are a's that are common. And whenever we combine those together, we get 3a. Again then, the numbers, we can see that there are number terms that are common. So we've got plus 2, another plus 2, and a plus 2. And what we get is plus 6. So whenever we're expanding brackets, rather than writing out the expression 3 times, so if we have 3 lots of a plus 2, or if it was even more ridiculous, if we had 10 lots of 7a minus 3. So instead of writing out 7a minus 3 and adding those together 10 times, what we can do is we can multiply the bracket and multiply into it. So we need to multiply the first term by the term outside. So we'll do 10 times 7a, and we would also do 10 times minus 3, and that would get us to 70a minus 30. So whenever we're expanding a bracket, we need to multiply everything inside the bracket by what's outside of it. So again, if we had 3 brackets a plus 2, if we multiply the 3 and the a, we'll get 3a, and multiply the 3 and the 2, and we'll get plus 6. So in our first set of examples, we want to expand, and expand means remove the bracket by multiplying. So it doesn't mean we write it wider or anything like that, it just means we multiply out the bracket. So we need to multiply everything inside the bracket by the 4. So 4 times a, and we're multiplying, so it's 4 times a is 4a, and 4 times 2 is plus 8. Again, where this is coming from, we've got a plus 2, plus a plus 2, plus a plus 2, plus a plus 2. We've got 4 a's, and we've got 2 plus 2 plus 2 plus 2, which is plus 8. But that's a real hassle, so it's much easier to remember to multiply everything inside the bracket by the term outside. So in the second example, we've got 9 multiplied by 2x. 9 lots of 2x get us 18x, and 9 lots of minus 3 are minus 27. In the third example, we've got minus 7 outside, so we're multiplying everything inside the bracket by minus 7. And I would really encourage you to put these lines in to show that we're multiplying. It doesn't take too much time, too much effort, and it's a really good way of reminding you to multiply everything by it. So minus 7 multiplied by 5x is minus 35x, so 7 5s are 35, the minus is going to make it negative. And then minus 7 multiplied by minus 8, we've got 2 negatives multiplied together, which is a plus, and then 7 8s are 56. Our next set of examples expand and simplify these expressions. So we've got 2 sets of brackets in each of these, and we're going to treat them separately and then add or subtract them depending on what they are. So here we've got 7 multiplied by x and 7 multiplied by 5. So 7 times x is 7x, and 7 times 5 is 35. And then we're adding on 3 lots of x and 3 lots of 4. So we're adding on 3x plus 12. So we can collect like terms. So we've got the 7x and then a plus 3x, and they'll combine together to give 10x. And then we've got the 35 and the 12, and they combine and add together to give 47. Now 8x plus 1 minus 5 upon x plus 2. Same idea that's going on here. So we've got 8 multiplied by x and 8 multiplied by 1. And that's going to give us 8x plus 8. So we're multiplying the 8 by the x and the 8 and the 1. Then we've got this minus 5 outside a bracket. And just as we did in an earlier example, so we multiply everything inside the bracket by the minus 5. So minus 5 times x is minus 5x. Minus 5 times 2 is minus 10. We need to collect our like terms. So we've got an 8x minus a 5x. 8 take away 5 is 3x. And then we've got positive 8 take away 10. 8 take away 10 is, of course, negative 2. So we get 3x negative 2. It's not, so some people, whenever we go through these, some people say things like 3x plus negative 2. But our rules for negatives, we've got the plus and the minus, so that simplifies up to a minus. And sometimes people can do the question in this format. So I've seen it before where people will write 8x plus 8 and then take away 5x plus 10. But remember, in that case, we've only multiplied the x by minus 5. You've multiplied 2 by 5, not minus 5. So you need to be really careful there. And then all it is just collecting the terms together and then writing them out as they are. So we can also expand a bracket by a letter. And it's important to remember that if we have an a multiplied by a, that gives us a squared. A times a squared gives us a cubed. So whenever you multiply the same letters together, the power increases. The other thing to remember, if we've got a and you multiply by b, that's just going to be ab. And if you had 2a multiplied by 3a, you multiply the numbers first of all. So 2 times 3 would be 6. And then a times a would be a squared. So those are the rules for multiplying letters together. So just in the same way that we had done previously, we need to expand out the brackets, and part of our working out is really showing these lines. So we're multiplying 4x by 2x and 4x by minus 8. So do the numbers first of all. So 4 times 2 is 8, and then x times x is x squared. And then 4 times minus 8 is minus 32. And there is no other letters there, so it's just 32x. We can't combine those in any way, so we can't simplify that down because x squared is not like x. They're not like terms, so we have to leave them in that format. Example 2 then, we've got this 7a upon 5a squared minus a minus 2. So we're going to multiply the 7a by the 5a squared by the minus a and the minus 2. So 7a times 5a squared, 7 times 5 is 35. And then we've got a times a squared, which is a cubed. Then we've got 7 times the minus, so that's going to be a minus 7. And then a times a is a squared. And then 7 times minus 2 is minus 14. And there's no other letter, so it's just 14a. And then the third example, we've got 9b upon 6xb minus 12. So we're going to need to multiply the 9b with the 6xb and the 9b and the minus 12. So 9 sixes are 54. And then b multiplied by x multiplied by b. We can do b times b to give b squared. And we've also got the x. Now we could have written that as 54xb squared, provided we make sure that the squared belongs with the b, then we're okay. It doesn't really matter. And then 9b multiplied by minus 12, we're going to get a negative 108. So 9 12s are 108. And then we've got the b as well. So the answer would be 54b squared x, take away 108b. Factorising algebraic expressions by taking a term out. Now we've looked at factorising before and we've thought about numbers. So whenever we're factorising 48, say, we'd be thinking, well, that's 1 times 48, or 2 times 24, or 3 times 16, 4 times 12, or 6 times 8. And factorising is writing a number as the product of 2 or more numbers together. So we could use product of primes and express 48 as 2 to the power of 4 times 3. But regardless, factorising is expressing something in terms of a product. And the same is true for algebra and algebraic expressions. So what we need to do is think of terms that multiply together to give 4x plus 6 or 5x minus 20 or whatever the expression happens to be. And the way we do that is to look for common factors, so either letters or numbers or a combination of them that will divide into each term. So in 4x plus 6, hopefully we can see that 4 and 6 have a common factor of 2. So we can put a 2 outside of a bracket. And then inside the bracket we're thinking, well, 2 multiplied by what gives me 4x. Hopefully we can see that's going to be 2x. And then 2 multiplied by what gives me 6. And the answer is 3. So the factorised form is 2 upon 2x plus 3. In the second example, 5x minus 20, the common factor. So what divides both 5x and minus 20? Well, that's going to be a 5. So we'll put a 5 outside of a bracket. And then we think 5 multiplied by what gives us 5x? That's going to be an x. And 5 multiplied by what gives us negative 20? Well, we know 5 4s are 20, but to get the minus, we need the takeaway sign in there. And then the third one, 12a take away 3. So the common factor this time is going to be 3. So 3 divides into 12 and also 3. So we need to put 3 outside of a bracket. So 3 multiplied by what is 12? That's going to be 4. And we need the a. And 3 multiplied by negative 1 then gets us back to negative 3. So what we're doing is we're looking for something that divides into each term, putting it outside the bracket, and then working to see what multiplies back to get the original function, or the original expression. So the last couple of examples looked at factorising out numbers. We can actually factorise letters too. So what we look for again is we look for a common factor. And the common factor, the common term between 5a and ab is an a. So both terms have an a. So that means we'll put the a outside the bracket. And we think, well, a multiplied by what gives us 5a? So a multiplied by 5 gives us 5a. And then a multiplied by what gives us plus ab. So the symbol's going to be a plus. We've already got the a, so a multiplied by b gives us ab. The second example, between the 7a squared and the 3a, the common factor is going to be an a. So we put the a outside the bracket, and we think a multiplied by what gives us 7a squared. So we need the 7, so that's going to make 7a, but we need an a squared, and a multiplied by a is a squared, so we need to put 7a. Then we need to think a multiplied by what gives us plus 3a, so we need the plus, We've already got the a, so all we need is the 3 there. And then in example 3, we've got 12xy and 7yz. The common factor there is a y. So we'll put our y outside the bracket. And we need to think, well, y multiplied by what gives us 12xy? So we need 12, and we also need an x. And then y multiplied by what gives us minus 7yz? Well, first of all, we need the minus. We've got the y, so we need the z, but we also need 7. So it's going to be minus 7z. And finally, we've got a couple examples where we have to factorize out numbers and letters. So what we're looking for is something that's common between 6x cubed and minus 10x squared. So the common factor here. So between the 6 and the 10, both of those are even numbers, so they'll both divide by 2. And between x cubed and x squared, there is an x common, but actually there's a higher power, and that's x squared. So whenever we're told to factorize, we need to take out the biggest factor, not just anything, we need to work out the biggest one. So x squared is the biggest common factor between x cubed and x squared. So we'll write 2x squared, and then inside the bracket, so we need to think 2x squared multiplied by what gives us 6x cubed. So 2 multiplied by 3 gives us 6. And then x squared multiplied by x gives us x cubed. Then we've got the minus 10x squared. So 2 multiplied by what gives us minus 10x squared. So 2 multiplied by minus 5 gives us our minus 10. And the x squared match up, so we don't need to do anything further there. Between 3xy and 18xy squared, so both terms in the numbers are divisible by 3, so we're going to take the common factor of 3 out. Both have an x term, so we're going to take that out as well. And I say both have a y, so we can take out 3xy. So we'll put 3xy outside the bracket. And then we need to think, well, 3xy multiplied by what gives us 3xy? So 3xy multiplied by 1. So it's not 0, so 3xy multiplied by 0 would give nothing. We need to get a 3xy, so we need to multiply it by 1. So we'll put a 1 in there. And then 3 multiplied by what gives us our minus 18xy. So 3 6s are 18, but we need a minus, so that's to take away 18xy squared. We've got the x's, they're okay. And then the y, so y multiplied by what gives us y squared, and that's going to be y. So the answer there is 3xy upon 1 take away 6y, and that's it, fully factorised. So again, anytime that a question would say to factorise something, what it's really saying is fully factorise, take out as much as you can.